Imagine holding a piece of history in your hands, a silent witness to a world that existed tens of thousands of years before us. That's exactly what scientists get to do when they drill deep into the Earth's ancient ice sheets. Today, we're venturing into the frigid, pristine landscapes of the Tibetan Plateau to uncover the secrets locked within a 30,000-year-old ice core. What they found inside isn't just a record of past climates. It's a discovery so mind-boggling, it could rewrite our understanding of life on this planet. So grab your warmest jacket, because things are about to get chilly and incredibly fascinating. Picture this: scientists bundled up against the biting cold, carefully extracting a long cylindrical sample of ice. This isn't just frozen water. It's a vertical timeline, a library of Earth's history. Each layer represents a season, trapping everything that was in the atmosphere at that time: dust, volcanic ash, pollen, and, as we're about to find out, something much, much more surprising. For decades, we've used these cores to understand past temperatures and atmospheric composition, charting the ebb and flow of ice ages. But a recent team of researchers decided to look for something different, something that was previously thought impossible to find in such ancient ice: life. Specifically, they were hunting for viruses. Now I know what you're thinking. Ancient viruses, that sounds like the plot of a disaster movie. But hold on, it's not what you think. These scientists developed a brand new, ultra-clean method to analyze the ice. Think of it like a viral archaeological dig. They had to be incredibly careful not to contaminate the 30,000-year-old sample with modern microbes. The process was painstaking. They worked in a freezing cold room, meticulously shaving off the outer layers of the ice core, layer by layer, like peeling an onion, to get to the pristine, untouched center. This was crucial because the outside of the core could easily have picked up modern bacteria and viruses during drilling and handling. They needed to be absolutely sure that what they found was genuinely from the deep past. And what did they find in that perfectly preserved ancient core? An entire lost world of viruses. The team identified genetic codes for 33 different viruses. And here's the truly shocking part. At least 28 of them were completely new to science. They had never been seen before. These weren't your common cold or flu viruses. These were phantoms from a prehistoric world, frozen in time, their last host potentially being an ancient plant or soil microbe from the Pleistocene epoch. It's a microbial zoo that has been in suspended animation for 30 millennia. This discovery is groundbreaking for a few reasons. First, it proves that viruses can survive being frozen for incredibly long periods. We're not talking a few years in a freezer. We're talking about surviving through ice ages. This has huge implications. As our planet warms and ancient glaciers and permafrost begin to melt, what else might be waking up from its long slumber? This isn't just a hypothetical question anymore. The Tibetan Plateau, like the Arctic and Antarctic, is one of the fastest warming places on Earth. The very ice cores that hold these secrets are now melting at an unprecedented rate. It's a race against time to study these ancient ecosystems before they disappear forever, potentially releasing their contents back into the modern world. But don't panic just yet. Most of the viruses they've found are likely bacteriophages, meaning they infect bacteria, not humans. In fact, studying them could be incredibly beneficial. Think about antibiotic resistance, one of the biggest challenges in modern medicine. These ancient phages, which have evolved for thousands of years to effectively target bacteria, could hold the key to developing new therapies. We might find novel ways to fight modern superbugs by looking at the ancient evolutionary arms race between viruses and bacteria. It's like finding a 30,000-year-old medical textbook with solutions to problems we're facing today. Furthermore, this research opens up a whole new field of science called paleovirology. By studying the genetics of these ancient viruses, scientists can understand how they evolved over millennia. How did they adapt to changing climates? How did their hosts change? It's like having a fossil record for the microbial world. We can see how viruses responded to the end of the last ice age, which could give us vital clues about how modern viruses might respond to our current climate change. It adds a whole new, invisible layer to our understanding of Earth's history. a history dominated not by large animals, but by microscopic life. This isn't just happening in Tibet. Similar research is being conducted in Siberia, Greenland, and Antarctica. In Siberia, scientists have already revived a giant, 30,000-year-old amoeba-infecting virus from the permafrost. And while it was harmless to humans, it showed that these ancient microbes can indeed wake up and become active again after being frozen for eons. Each new ice core and permafrost sample is a potential treasure chest of biological information, containing snapshots of life from different geological eras. Who knows what else is waiting to be discovered? Perhaps we'll find ancient fungi, bacteria, or other life forms that could revolutionize medicine, agriculture, or our understanding of evolution itself. So what started as a daring exploration of a Tibetan ice core has turned into a profound revelation. We've discovered a hidden, frozen biosphere, a lost world of viruses that challenges our perceptions of life and survival. It's a stark reminder that our planet holds deep secrets and that the past is never truly gone. It's just waiting to be uncovered. As the ice melts, we are faced with both a risk and an incredible opportunity. The risk of unknown pathogens emerging, and the opportunity to learn from them, to unlock ancient remedies and understand our planet's deep history on a microbial level. The work of these scientists is a race against the clock, a mission to read the pages of Earth's frozen library before they melt away into oblivion. What an incredible journey into the distant past. It just goes to show that some of the biggest discoveries can come from the smallest, most unexpected places. Thank you so much for joining me on this deep dive into the world of ancient ice. If you found this as fascinating as I did, please hit that like button and subscribe to the channel for more explorations into the wonders of our world. We'd love to have you as part of our community of curious minds. Until next time, stay curious,